Hello, hello. All right. Just checking to make sure that I am recording the audio instead of giving you guys silent movies like a few times before. All right. This is a online lecture for the upcoming topic. You can see that we are a little bit behind in terms of our schedule, but I think we can catch up once we get through, all the really thick stuff that we'll have to go through currently, which is basically how to use the virtual machine effectively. So right now, I'm in topic 10, and topic 10 talks about how to use how to use network shares. In this case, it's about how to set up Samba. But to set up Samba in the virtual machine and have access to it in the host environment is a little bit tricky because we cannot just forward a few ports and call it a day. It is much better if we can use a much more general approach. In other words, the way we connect SSH to our virtual machine in the last or the current homework assignment, it's great if we only have one or two ports to forward, but it doesn't work that well when we have many ports to forward, especially when we have to forward the same port to the same number. That simply does not work very well. What we want to do is to use Virtual Distributed Ethernet, or VDE, instead. There are several links here in topic 10. I encourage that you read every single one of them, even though they do overlap in terms of the instructions. The last one, which is the second last one, tax more detailed VDE write-up. This one is a really good follow-through type of instruction. In other words, it gives you most of the instructions that you need in order to set up VDE. So let's go ahead and take a look. I click on it already, so here is the screen of that one. And we start with, let's go ahead and start with section 2. A network switch is an OSI level 2 network device, and in this case, the virtual network switch is also quote-unquote a level 2 network device. So it's not aware of TCP/IP. It is one level below TCP/IP, and therefore it will also work with protocols like ICMP and many other non-TCP/IP protocols. And this is one thing that you will notice is when we use the old current way of connecting the host environment to the guest environment so your guest can get out to the internet, ping doesn't work, and that's because ping is an ICMP format. It's an ICMP. It uses the ICMP protocol and not TCP/IP, and port forwarding only works for TCP or UDP connections. And in this case, we want to make it more general, and VDE will be very helpful in this case. VDE is a virtual distributed network switch. It offers multiple network ports that can be connected to virtual machines. So essentially, what that means is, if you look at a virtual machine as a virtual box, as a virtual server, VDE is a virtual switch. So just imagine a off-the-shelf switch that you can buy from Fry's, except this one is virtual. So you have all the different ports, all the different connectors, and it behaves just like that. And this part is already done. The host environment, your live image, already has VDE installed. You do not need to install VDE in the virtual server, because the virtual server is living in the virtual world and it should not need to know anything about VDE2. So that's fine. We don't need to do this step anymore. And for those of you who are curious and say, well, I'm not quite sure that it is actually installed, go to a command prompt. You can do this even in as user, but if you do it as root, that's fine too. You can just say aptitude, or do it as root in this case. So we'll switch to root first, and then you can say aptitude install VDE2. It's already installed, so it's not going to do anything. It will just come back and say no packages will be installed, upgraded, or removed because it is already installed. Okay, so we are done with this step. Alright, the next step, which is in section 5, starts the actual process. The first command you have to use is vde_switch-s/temp/switch. Well, let me explain each part here. The command is called vde_switch, and you should run it as a regular user and not as root. You do not need to run this as root. The second part is an option. This is basically saying, okay, where do I create the special files in order to implement this virtual switch? And this is the location. You don't need to use exactly this path. You can select any path that the regular user has access to. It's just that I use this particular path, throughout all my notes. So it may be helpful if you use the same convention. What this command does, is it basically powers up the switch, which is helpful. But don't do it yet, because we'll also have to supply some additional options to this command. So what I'm going through right now is just to explain the basic arguments to these commands. The second one is called slurp VDE. Now this command slurp VDE can only run after VDE switch has been run successfully. Because what this does is it implements a DHCP server along with a NAT device. In other words, it will implement both a DHCP server and also a gateway, so that any virtual machine connected to the virtual switch can get its IP address and also go through your host environment potentially to get out to the internet. Actually, it does go through the host environment to get out to the internet. But the question is, how does the host environment connect to the switch? So we'll talk about that later. To run this command, you have to supply this switch here, which basically tells the program where is that virtual switch created, and this path must agree with the other path here, with the vde_switch command. The other two options, --HDCP, basically says we do want to run the DHCP server, and here we want to run it in daemon mode. So don't run this command yet, because we'll also go through a few. I'll explain a few more options before we actually run it. And then this part here talks about the gateway address of the virtual machine is always 10.0.22, and the DNS server is 10.0.23, and the net mask is 255.255.255.0. We won't do it for this 1/3 of the semester, but in I think the second or the third of the semester, we'll talk about how to implement your own DHCP server. In that case, you will basically disable this option here, so that one of your virtual machine in the virtual network will act as a DHCP server. But for now, this is basically what we want. Okay, and let's move on to the next page. The next page talks about how do we connect the virtual machines to the virtual switch. And what you do is, instead of using this option here, which you should be using for your file permission homework assignment, you have to switch it to something that looks more like this. Basically, we are switching from user mode networking to VDE mode networking. We'll go through this also sometime when we actually go through the command options. And the last part here talks about if you have multiple virtual servers that you want to connect to the virtual switch, you also have to specify the MAC address to make sure they do not have the same MAC addresses. Because the default MAC address is, I think this is the default MAC address, so you have to make sure that none of your virtual machines, no two virtual machines will use the same MAC address, because that simply does not work in a virtual switch or in the real world. And that's it for this particular module. So let's go ahead and read another note here. there's one more, VMs and VDE. So let's try to open this up. Okay, so with this one, there are more explanations, and it also has more commands. And we'll go through these step by step. You should also read this on your own. I'm just quickly going over the commands and show you how things are done. But you have to learn why we have to perform all these different steps. So what we'll do is go ahead and start a command line and start to execute these commands. The first command you have to run it as root because we are creating a new interface. The command line or the command is called TUN, tunnel, CTL, which stands for control, so this is tunnel control. And what we're doing is we are allowing the user in this case, and you can obviously change user to your own account name or some other account name. So in this case, I'm just testing it with the default user. And we are creating a interface, a tunnel called tab 0. Basically, it creates the network interface tab 0 and make sure that user has access to it. And that should be the feedback coming from tunnel control. You can do a Ifconfig, and it doesn't come up automatically because we have just created the interface, but we really haven't done anything to it. The second command, which is VDE_switch -s blah 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 blah, you can run it as a regular user, so you can get out of the root mode and get back into a regular user mode, and you can run this command -s/temp/switch. So this part is the same as what I have explained a little bit earlier, except the last step adds this portion here. Now let me explain why we need this portion here. The virtual switch by default does not connect to the host environment at all. In other words, you can have your virtual machines to connect to the virtual switch. They can talk to each other. They can even connect to the internet, but they cannot talk to the host environment. You cannot SSH into one of the virtual machines. You cannot access the virtual machines at all. That's because, conceptually speaking, logically speaking, you have not plugged in the host environment into the virtual switch. This option here, tab 0, is plugging your host environment into the switch that you are powering up. Unfortunately, you cannot do this later on, so you have to plug it in as you power up the virtual switch. You cannot plug in the host environment to the virtual switch later on. So that's a very important step, because if you forget this option here, that means your host environment, your live image, would not have any access to the virtual machines. So let's go ahead and run this command. It does not come back because I did not specify --daemon at the end, so it's not running in daemon mode. It is actually just running in a regular mode. So that's okay. We can always open up a new tab to run the next command. The next command is slurp VDE, and once again, what this command does is it connects. It does two things. Let me just write the command here: slurp VDE. This part here has to be consistent with the VDE_switch command, because that tells the program where are we going to find the virtual switch. The last portion here, DHCP, is basically saying, do we want to run the DHCP server? So in this case, yes, we do want to run the DHCP server, so we have to specify this option here. And then once again, we just press the enter key. It doesn't do anything. It's just it does not come back because once again we did not run it in daemon mode. Okay, now at this point, let's open up another tab here, and at this point what we can do is we can actually take a look at our ifconfig. You can actually run ifconfig when you're not root. You just have to supply the full path name, which is /sbin/ifconfig. And you can see that tab 0 is not connected yet. It doesn't show up here, and that's because we have not identified tab 0 and say, okay, go ahead and try to get an IP address. We have not brought the interface up, but it's actually there. It is connected. We just have not brought it up yet. The next command here, you can see this part here. The last part is to get an IP address for tab 0, but we won't do this step yet. We'll go ahead and perform the next step, which is connecting your virtual machine, powering up your virtual machine, and connecting it to the switch. And if I remember correctly, my notes here actually has an error, but we'll go ahead and find the error as we type the command. When you're in doubt, just go ahead and do the man page, and then you can go to -net space VDE, and that will show you the options that you can specify when you use VDE type of networking. You can see that you can specify the VLAN, which you should do, but the default of 0 should work in most cases. You have to specify the socket. That's the same as the -S option when we run VDE switch. And you can optionally specify the name, you can optionally specify the port, but we'll leave it unspecified to let the switch decide which port to connect to. And let's go ahead and start our virtual machine. So you start the virtual machine using the usual command, and it makes sense to put it into a script so you don't have to retype the same thing over and over again each time. And we'll go ahead and specify the hard drive image file. So here's the hard drive image file, and then we'll go ahead and specify the network mode. So we'll specify -net nic, VLAN 0. All that VLAN equals 0. All this one does is to specify, yes, we do want to create a network interface called a NIC, and we call that VLAN 0, so that from now on we can refer to this as VLAN 0. And then the next one is also -net, but this time we are not creating a NIC. This time we are associating a network interface to a particular way of connecting the virtual machine to the outside world. In this case, we want to use VDE mode, and then we can specify all the options that goes with VDE. And we have to specify the socket. The socket is temp/switch itself. And you can also optionally specify the rest, all the other options. I am not going to specify any more than what I need to, so I'll just leave this one the way it is right now. And I think my virtual machine is ready to get started, so we'll press the enter key. And you can see the virtual machine is starting up. As this is starting up, it's a good time to continue with our last command here. The last command is basically to say, okay, the host environment still has no access to the virtual switch because I have not brought that up yet. And to bring that up, you can as root. So this time you do have to switch to root again, and then you can run dx-client space tab 0. In other words, you're telling your host environment and say, go ahead and try to get an IP address for the network interface called tab 0. So we press the enter key, and it is successful. You can type ifconfig again, and this time it shows you that you have one more interface called tab 0, which is of course not a real network interface. It is a virtual interface to connect to the virtual switch. So here is our real interface, our real wired interface ETH0, and here is our virtual interface connecting to the virtual switch. And the IP address of that is 10.0.2.15, which is assigned by, guess what, our slurp VDE program, because we ran that one with the DHCP option. So now we have two interfaces. Now one potential problem with this is we also have two gateways. So you have to make sure that our routing is going through the right gateway and not the wrong one. And it is set up correctly because you can see the gateway, the default gateway. The default gateway is 10.0.3.2, instead of 10.0.2 something, because if the default gateway is 10.0.2 something, we cannot really get out to the internet, because all it does is to connect back to the virtual switch. 10.0.32 it allows us to get out of the machine, the actual physical machine, to the actual network. All right, now our virtual machine is now up, and then what we'll do is to log in as root first. And the first thing we want to do is to run Ifconfig, because we want to see if the virtual machine is connected to the network. And the answer is yes, it is connected to the network with an IP address of 10.0.2.16. So now you can see how the host environment, which has an IP address of 10.0.2.15, can connect to the virtual machine, which has an IP address of 10.0.2.16. Remember what I said a little bit earlier, that a switch operates at OSI level 2 instead of level 3. So that means ICMP should work too, ping should work. So the first thing we want to do is to ping 10.0.2.16, and it's pinging the virtual machine just fine. And inside the virtual machine we can do the same thing. We can go ahead and say ping to 10.0.2.15, which is the interface to the host environment, and that works as well. So this is good. This is very encouraging, because it means the virtual machine and the host environment now has connections. Okay, so that's good. Our next test is to see whether we can SSH from inside the host environment into the virtual machine. Of course, the first thing you want to do is to check whether SSH is actually enabled in the host, in the guest environment in the virtual machine. There are really several ways to do it. One way is to use netstat NLTP, which will show you all the ports and what is responding to that port. You can see that port 22 is listened to from all interfaces, and the program that's responding to that is SSHD. So we know SSH is running, the SSH server is running. So now from the host environment, we'll go ahead and try to see if we can SSH into the virtual machine. So we'll go ahead and SSH into a particular account that I set up at 10.0.2 what was it? 16. And the connection is successful. And now I'm inside the virtual machine. I also changed the host name of the virtual machine to become VM1 instead of Debian. So this way it is easier for me to tell whether I'm running a command on the virtual machine or whether I'm running a command in the host environment. Let me show you how you can change the host name easily. As root, you want to go to the command. There are two files to modify, and you should modify both of them at the same time. The first name is host name. Oops. So the first one is host name, and what you want to do is to change that to the name that you want for this particular host. And then the second one you want to modify is etc/hosts. I keep forgetting that we don't have Vim here. And in this one, you just want to assign 127.0.0.1 to, or in this case 127.0.1.1 to that name also. But you need to remember to change both files if you decide to change the host name. And that's, that makes it easier. Okay, but here's the question. We did not actually specify how to do port forwarding from the host to the virtual machine. So how come we can do SSH? How come we can SSH into the the virtual machine? The answer is, well, they are already connected by a network switch. So basically, we don't have to specify which port gets forwarded to which port from the host into the guest operating systems, because they are basically connected. Basically, all the networking stuff should work between the host environment and the guest environment. So this is a bare minimum setup before we set up Samba because Samba requires more than one port in order to work, and we don't want to go through the trouble to have to port forward multiple ports between the host environment and the virtual server, and this is a real basic setup to get it done. So let me just recap the commands here. The first command is a little before that. The first command is this command here, and you have to do this every single time after you start up your live image, because the tab0 interface does not get stored. So when you power down your host environment, the tab0 interface basically disappears. So every time you power up your machine, you have to do it again. But once you have done it once, you don't have to do it again. The second command you want to do as a regular user, not as root, is VDE switch, and make sure that you type in the last option so that your host environment is also connected to your virtual switch. The second command you should run is this command here, slurp VDE-as the path to the switch, and also --DHCP. For now, we'll enable --DHCP because we are not going to implement our own DHCP server yet. And then the next command is to run the virtual machine. To run your virtual machine and have VDE enabled, you need to specify two things. One is this one here. One is to specify that yes, we do want to have a network interface card and assign that to VLAN 0. The second one is the important one. The second one is the highlighted portion here. You specify that we want VDE mode connectivity. The socket to the VDE switch is /temp/switch in this case, and this is the bare minimum that you have to specify in order to connect a virtual machine to the virtual switch. Once you are in the virtual machine, there's a fourth command too. The fourth command allows your host environment to be assigned an IP address from the virtual switch, and that command is, I know it's here somewhere. That command is dxclient tab0. Basically, you're telling the program, you're telling the system to get assigned an IP address through the network interface called tab0. So these are the steps, in order for you to start a virtual switch, to connect your virtual machine to the virtual switch, and then also connect your host environment to the virtual switch. So that once this is all set up, this is the most general setup to allow communication between virtual machines and also from your host environment into any of the virtual machine. And this is the main reason why we have the live distribution, because it is much harder to do this in Windows. You will have to install certain things, and we don't have administrative access to the machines, so it would just create a big mess, if we had gone for a Windows solution. But the live distribution allows you to do all this because all the commands and all the tools are built into the live image already. So this is there's no homework assignment for this part. We will have a homework assignment for the Samba part, so just stay tuned, and we'll have the next homework assignment that will make use of the virtual switch. You may want to go through this once, just to make sure that you have no problem establishing the virtual switch and connectivity between the host environment and the virtual server before we even move on and talk about the homework assignment. Thanks for watching, and there'll be another recording soon.